This is how mathematics controls every space mission, the mathematics behind spacecraft. How maths lets us leave the Earth. Introduction. A spacecraft is not guided by instinct or trial and error. Every launch, orbit and landing is controlled by mathematics long before the rocket ever leaves the ground. This lecture shows how equations decide whether a spacecraft succeeds or fails. Escaping the Earth. To leave the Earth, a spacecraft must overcome gravity. Gravity depends on the mass of the Earth, the distance from its centre. The gravitational force follows in an inverse square law. If distance doubles, gravity becomes 4 times weaker. This single mathematical rule determines how much fuel is needed to escape. Now, escape velocity. A spacecraft must reach a minimum speed called escape velocity. For Earth, this is about 11.2 kilometers per second. This number comes from equating kinetic energy, movement, gravitational potential energy, gravity. If the spacecraft reaches this speed, gravity can never pull it back. Orbits are controlled falling. An orbit is not floating. A spacecraft in orbit is falling towards the Earth, missing it due to its sideways speed. Mathematically, gravity pulls inwards, velocity keeps it moving forward. The balance of these two creates circular and elliptical orbits. Circular and elliptical orbits are described using geometry. Circular orbits have constant distance from the Earth, where there would be an arc, constant radial distance from the Earth. Elliptical orbits change distance during motion. The shape of an orbit depends on the speed and the distance of launch, direction of launch. Small mathematical changes lead to completely different paths. Trigonometry in space navigation. Spacecraft do not travel in straight lines. Engine burns are timed using angles, thrust direction, orbital plane, entry angle into atmospheres. A tiny angular error can miss a planet by thousands of kilometers. Trigonometry ensures precision. Timing and calculus. Space missions rely on timing. Calculus is used to predict future positions, adjust velocity smoothly, minimize fuel use. Engineers calculate rates of change in position, velocity and acceleration. Without calculus, long-distance space travel is impossible. And why gravity assists work. Spacecraft often use planets to gain speed. This is called gravity assist. Mathematically, momentum is exchanged, energy is conserved. The spacecraft steals a tiny amount of the planet's motion without fuel. Why space maths must be perfect. In space, no corrections are easy. Errors grow rapidly. Fuel is limited. Maths ensures mission work the first time. The big mathematical idea. Space travel is not about power. It's about precision, prediction, and equations. Maths turns empty space into a navigatable map. And conclusion, a spacecraft succeeds long before launch. It succeeds on paper. Equations decide where it goes, how fast, whether it comes home. Space is conquered by mathematics. And that's the mathematics behind spacecraft, or how maths lets us leave the Earth.